Today we are asked to graph a function, this function here, and it doesn't have any x-intercept. So how would we do that? Well, let's first start off how we would graph a normal function, as explained a couple lessons ago. We do this the square technique. We divide into 4 pieces and start solving. So we know the 5, which is the y-intercept, and 0, 5. And this 5 here also goes in down here. And we also know x squared, which goes up here. So what two variables multiply to x squared? Well, x times x. And to 5, to multiply, what two numbers multiply together to create 5? Well, 5 times 1 and -5 times -1. So, well, let's try these possibilities. 5 and 1 equals 5, 5x here, and x here. If we add these two together, equals 6x, not -3x, what we're asking. So what about this option here, -5 times -1? Let's try it out. So we have -x -x plus -5 is -6, which is not -3, which is what we're looking for. So this function here is non-factorable, which means there are no x-intercepts. You can't factor this equation. So what will we do now? We already noted that the y-intercept is 0, 5. So to find the vertex, we have to have two points that have the same y value. And this is how we will do it. Okay, since there is no x-intercept, and that's what we usually use to find the vertex, we have to find something called the line of symmetry, which is this dotted blue line on the graph g of x. This is just an example. This dotted blue line is found between 2 points that have the same y value, for example. So here, on the x-intercepts, they both have the same y value, which is 0. Suppose this is point -7 and point -3. -3, 0 and -7, 0. They both have the same y value, 0. Suppose two other points here. These have the value of 20 and 20 on the y point. They are both equally distant from the line of symmetry, which is the same line vertically of the vertex. So we will now use this, the y-intercept, to find the line of symmetry. How? Well, by using the y value 5. So we take our function here, x squared minus 3x plus 5. And we equal it to 5 because we want to find another point that, when inputted an x value here, will give us 5. Well, how do we do that? We'll just solve for x. Now we're equal to 0 equals x squared minus 3x. What I usually do is just guess the random numbers. What about, let's try 2. 2 squared is 4 minus 3 times 2 is 6. Not possible. What about 3? 3 squared is 9 minus 3 times 3 is 9. 9 minus 9 is 0. 3 is another x value that is on the same y line as our y-intercept, 0, 5. So another point would be 3, 5. Okay, so now we have 2 points with the same y value. We can now find the line of symmetry, which is also you can find the vertex using the line of symmetry. So how do we find the vertex? We have to find the x value of the vertex, and how do we do that? By adding the 3 and the 0, and then dividing it by 2. would give us 3 over 2, or 1.5. And now, since 1.5 is the x value of the vertex, how do we do that? It's just an x value. We can plug it into the equation to get what the y value of the vertex is. And then we have 3 points, making it possible for us to graph the function. Let's do that. 1.5 squared minus 3 times 1.5 plus 5. Now we're just going to solve for f of 1.5. 1.5 squared is 2.25. Minus 3 times 1.5 is 4.5 plus 5. Adding all this up together equals 2.75. And we found our vertex, which is 1.5, comma 2.75. So we have our 3 points. The y-intercept, 0, 5. Another point on the graph, 3, 5. And the vertex, 1.5, 2.75. Let's start plotting these points and then graphing. So the y-intercept goes first, 0, 5. 0, 5. There's the point here. The other point on the graph, 3, 5. 3, 5. And the vertex, 1.5, right there, and 2.75. So 2, 2.5, 2.75. Now we have 3 points. We can start making a parabola, and that is our graph. And that is how you graph a function without it having any x-intercepts. Thank you.